Nonlinear regression functions using R. I have already discussed nonlinear regression functions and nonlinear regression functions using stata. At the moment, I am going to discuss nonlinear regression functions using R, and our questions remain the same. All these three questions which we are going to answer with the help of 7 models, and which model to use, which model not to use is always a subject, always require a lot of thinking. Use your head, use your expert judgment, exercise judgments, decision making with the help of experts, because models are always helpful but not exact. Even in architecture, when people follow laws of physics to model their to have their architectural models, those models even may collapse. Alina Kemper, if you see it, won best architecture award, but the structure collapsed within first 24 hours. And in economics and social sciences, obviously we have more complications, and therefore we cannot have a mechanical recipe for every application. Data analysis is really not very simple, and so try to have precise questions. If you have precise questions, you may have precise answers. We'll try to reproduce these 7 models with the help of R. Well, I have already shared a link of all the replication codes used in chapter 8, nonlinear regression functions. You can use all these codes from here, and here I am going to reproduce it for you in for your convenience. Okay, I am going to have library tidyverse, library read Excel. This is data where I have, you can just go and import your data like this way as well. Import from Excel and you can read the data where it is, or you can have this your working directory. I have California school data. Now I am here plotting GG California school. X is average income, Y is test score, geom point, scatter plot. Library GG theme, basically you can use economics theme, you can use Tufte theme. If you write down here GG Tufte, it's okay. If you write down here PP1 plus theme underscore economist, you will have the economist theme here. So this is what theme you want to have. Okay, you can give a title, fine, probably I should have plus here, and now you have a title here as well. Now if you want to have linear fit here, so you see here the linear fit does not seem a good one, as we have mentioned in our nonlinear regression functions video as well. So here it's a quadratic fit, and now we want to compare whether quadratic or linear, and or this one is basically polynomial x cube, and this is log of x. So by taking log of x variable and on the other hand taking cube of x variable, x square, x cube, though both are very close to fit, but log x has convenient interpretation, so therefore we may use this one. I have shared all these codes, and you can use ggplot. Here I have also included quadratic as well. Cubic, quadratic, and log of x. All these curves are fit together on one plot. Library LM test and library sandwich for you see heteroscedastic corrected standard errors. California school data, we have generated a dummy variable for percentage English greater than or equal to 10 and less than 10. We have generated California student teacher ratio square, student teacher ratio cube, and we have regressed the models used in the equation. You can have these coefficients with standard errors corrected, that is heteroscedastic corrected standard errors. Similarly, you can have model 5. Now you have restricted model, unrestricted model. Use F test, and you will have F test is this p value is F test is 1.847.175. So model 5R and the upper model are more or less similar. You can impose those restrictions. ggplot to ggplot, and now you can see from this scatter plot, if I zoom it, Okay, just a minute, it's zooming. Okay, now you see these are your cubic fits, but in general what do we see? That slope difference between students where percentage English learners are low, that is this blue line, and where they are high, this one, the slope remains more or less except at the very beginning. So therefore we can say that reduction in class size, reduction in English percentage learners matters a lot in the very beginning or in very small class size. Means if class size is 16 and you make it 14, it will and percentage English learners are low, then it will have good impact. Otherwise, more or less results are same. You can read Stock and Watson book. Now I am going to produce these 7 models used in your book, and we have these 7 models reproduced here. You can present these models as I have presented in front of you here, or you can see these models are presented in nice format, in this format, so you don't need any editing or anything. You can do it at, just by using Stargazer library, and you can interpret these results. You can understand these results by reading particularly last section of chapter of Introduction to Econometrics by Stock and Watson. Please read it to get maximum out of it, and those who are already good, they can just browse it. Okay, thank you for watching. Take care.